Welcome to video 4.3. This video is the second video on naming or nomenclature, and it is going to teach you how to use the second type on naming ionic compounds. So the point of this video is to help you determine what type of ions will use the type 2 naming system. And then in this video, you'll also write formulas out and write the name of the compounds using this type 2 nomenclature rule. The only really vocab term in this is going to be type 2 ions. And really this video is just an add-on or a second version of what you learned in the last video of just our regular ionic naming nomenclature. So previously, we looked at the type 1 rules, where we just named the element in the cation version, and then we just named the anion, and we added the ending IDE. So we had things like sodium chloride or lithium bromide. This type 2 is very similar, except there's only one difference. Your type 2 ions are the ones that are here in the D block. When you look at your D block or you look at your transition metals, you're going to notice something about them and their oxidation state. So type 2 is going to use D block transition metals, except for zinc and silver, and then a few other non-traditional or non-D block elements like tin and lead. But typically we're just dealing with elements here plus tin and lead, which are over here. And the reason we're using this type 2 method, the reason we have to have an add-on per se, is that some ions, some transition metals can have two charges or two oxidation states. So what we see here is that when I was looking at my periodic table, and what we learned yesterday is that all the type or group 1 and group 2 elements all had just one oxidation state. They're either going to be +1 or +2. That was pretty straightforward. But now that we get to our transition metals, we begin to see here that these guys have multiple oxidation numbers, meaning they can form multiple ions. So as they form these different ions, we have to indicate which ion we're using in the compound when we're naming it, or that charge of that different ion will determine our chemical formula. So what we're going to do here, what you're going to see is an example here, iron, chloriron. Iron can have a +2 ion charge, or iron can have a +3 charge. And so iron 2 chloride is different than iron 3 chloride. So therefore, we come up with a second way of naming, which all we're doing is simply adding in a Roman numeral when we have multiple oxidation numbers for the same element. So it's a pretty simple method. It's the same thing you learned last video, except you're just going to learn how to incorporate this Roman numeral based upon the charge of the cation or based upon the charge of the transition metal. Sometimes this is called the stock system. For our class, we're going to just call this the type 2 system. And again, how do you find the oxidation numbers on your periodic table? They are listed right underneath the atomic mass and right above the symbol name or the symbol. And you can see all these D block elements plus tin and lead have multiple oxidation numbers, and we're just trying to account for that in the way we name and write our formulas. So how do we do it? Well, we do it, and I'll show you if my So here you can see how we're going to do this. So you'll watch me practice it. So to ID the name, to be able to name a type 2 compound, first of all, we just have to determine the charge on the cation, or in other words, the transition metal, or the D block element. And then we're just going to write a Roman numeral. Roman numeral for 1 is just an I. Roman numeral for 2 is 2 I's. And I'll show you on the next slide all these numbers. So for example here, if I have lead with a chlorine with 4 chlorines there in my formula, what we can do here is we can write out the name, but we have to include the charge for lead. So how do you do it? Well, we're just going to do the opposite of what you saw in the last video. Remember that cross idea? Since there's a 1 here, we can see that chlorine has a -1 charge. Since there's a 4 here, we can see lead will have a +4 charge. Remember, cations are written first, anions are written second. So since there was a 1 here, we have a -1. Since there was a 4 here, we have a +4 here. So all you do to answer this is you would write down lead chloride just like before. But when you check your periodic table and you see that lead has multiple oxidation numbers here, you need to tell me which one it is. And in this case, it's a +4. So you would write the Roman numeral for 4 down. Again, look at iron sulfate. How would I name this guy right here? How do I know if this iron has a positive +2 charge or a +3 charge? Well, let's do exactly the same thing we did before. Let's take that 2 and put it here. But since it's the anion, it's going to be -2. Take that 3, put it here. Since it's the cation, we call it +3. So now I know that this iron has a +3 charge from our cross method. And so when I go to name it, I'm going to write down iron sulfate. Again, iron. And then we're going to find sulfate on the side for our polyatomic ions. He's right here, sulfate. And so, but since I see an iron has multiple oxidation numbers, I will simply write Roman numeral 3 in here. So again, this naming system is very similar to what you just did. You're just adding in a Roman numeral based upon the charges of those elements. So here again is just in our slide to show you the different Roman numerals we'll use. 1, 2, 3, 4, 5, 6, 7. If I want to write Roman numeral 8, it's just another V with our capital I's. Roman numeral 9 is the same way. I'm sorry, with 9, you're going to write your I, and then you're going to use the X there. And then the last one will be 10. So these are your Roman numerals 1 through 10 that you will use. And so then now let's practice. Go ahead and pause the video, try it yourself, and then when you're ready, open it back up and you can watch how I do it with my own hand. All right, welcome back. So first way to do this, we're going to write out the formula. So we're going to take this and we're going to turn it into what's called the formula version. So again, I have 10. I'm going to use my periodic table. I'm going to see that 10 is the symbol SN. Then I'm going to see 10 has a Roman numeral 4 here, which tells me we're talking about 10 plus 4. And then I have oxygen. And we know from here that oxygen has a -2 charge. You're going to do your cross method. This 4 goes here. This 2 goes here. Just simply saying I need 4 oxygens to balance out the 2 10s here to get my charges to cancel out. And then again, like before, I want you to rewrite this, not showing the charges. So you would simply rewrite your answer like that. And this would be the correct way to write the chemical formula. Next one. We got copper, which is going to be Cu. We see he has a +1 charge that comes from here. If I look at my periodic table and I find copper, I see he has multiple charges. So I have to use the one given here, +1. I write down sulfate, look on here. Sulfate's over here, SO4. My sulfate, again, has a -2 charge. I know that because it's right there. Sorry, right there. And so then now, again, I just cross my numbers over, and then I rewrite this in the way it should be shown. Again, there's only a 1 here, so I don't need the parentheses. And then that would be my answer for that one. The last one, lead phosphate. Again, we're going to find lead as Pb. My lead's going to have a +2 charge here. My phosphate's going to be PO4 with a -3 charge. And again, that's in parentheses. Again, you get that off your periodic table. And again, I just switch my numbers up. I cross them. And then I rewrite this in a very clean fashion. So Mr. Lawrence can easily see that I know what I am doing. All right. Now, go ahead and pause the video and try to do the opposite. Let's try to reverse it out. Welcome back. All right, so now how do I take the formula and write out the name? So we'll do the same thing we did up here. We're just going to reverse our order. So you see that we have a 3 here. So we're going to put the 3 here, and it's going to be a negative. We see that there's a 1 here. So I'm going to have a 1 here, and that's going to make it positive. So now when I go to write out my name of copper nitride, I have to include my Roman numeral. Why? Because if I look at copper on here, he has 2 oxidation numbers. And so therefore, that +1 simply tells me I put a Roman numeral here. The next one, again, my 2 goes here, and it's a -2. My 5 goes here, my +5. Now I just write it out. We have vanadium. We have, this is sulfite. Again, look at the side of your periodic table to find it. And because vanadium has multiple oxidation numbers, I have to tell you which one it is, and it's the +5. Roman numeral for 5 is the V. Last one here, I have my 2, This one is nothing, so it's just a -1. So the 1 communicates here. So I go to write it out. I write out strontium, nitrite. I'm sorry, that's nitrate. And then now I go back and I look at strontium. Strontium here only has one oxidation number. So here I do not include the Roman numeral. I don't need it. So we're going to use the type 1 system we learned on the last video. So again, you only use the Roman numerals if those compound or those elements have multiple oxidation numbers. All right. So long story short, type 2 compounds have cations that are in the D block. These D block elements have multiple oxidation numbers, and so we have to show Roman numerals to indicate the charges. Our exceptions here are zinc and silver. They only have one oxidation number, and so therefore we don't use the Roman numerals for them. But then we also include lead and tin. Even though they're not in the D block, even though they're in the P block, we're still going to include them because they have multiple oxidation numbers. Have a great day.